In question 3, we're given a function of 3 variables, f of x comma y comma z equal to x squared minus 2y squared plus 3z squared, and we're interested in the point P with coordinates 2, 3, negative 1. We want to find a couple of things here. We want to find the maximum rate of change of f at this point P, and we want to find the unit vector that points in the direction of this maximum increase. Now, if you've just watched the video for question 2, there we had the option to use the gradient or not. It was certainly a reasonable way to proceed, but we fundamentally didn't need it. In question 3, it's all about the gradient. Because the gradient, the way we interpret the gradient geometrically, is that it is the vector that points in the direction in which the function increases as much as possible at a given point. And the norm of the gradient represents that maximum rate. So essentially what this question is really asking us to do is to find the gradient of the function f at this point P, find its unit, the unit vector in the same direction, which means finding its norm. Well, the norm is the other thing we're asked to find, the maximum rate of change. And so once we've got the gradient and its norm, of course we divide the gradient by its own norm to get the unit vector, and that's all that's involved here. So the gradient vector, remember, is just the gradient where each component is the corresponding partial derivative of the given function. So in this case, we've got a function of three variables. The gradient function will have 3 components. The first component will be the partial of f with respect to x, which is 2x. The next component will be the partial with respect to y, which is negative 4y. And the last component will be the partial with respect to z, which is 6z. The gradient specifically at the point P, so at the point 2, 3, negative 1, well, that's the vector 2 times 2 is 4, minus 4 times 3 is negative 12, 6 times negative 1 is negative 6. So that is already a vector that points in the direction of maximum increase. It's just not the unit vector that does so. Next up, we'll get the norm of the gradient. So that's the square root of the sum of the squares of each component. So that's 4 squared, which is 16, plus negative 12 squared, which is 144, plus negative 6 squared is 36. So let's see, that's the square root of 196, which is 14. And so 14 is the maximum rate of change. That's the norm of the gradient at the point. That's as much as you can possibly find this function changing, no matter which direction you head from the point P. So 14 is the maximum rate of change. The last thing we have to do now is to find a unit vector that points in the direction of maximum increase. So in other words, a unit vector pointing in the same direction as the gradient. So a unit vector pointing in the direction of maximum increase. That's going to be the gradient at 2, 3, minus 1, divided by the norm of the gradient at 2, 3, minus 1. Both things we've already computed. So that's going to be the vector 4, negative 12, negative 6, divided by 14. So that's 4 over 14, which is 2 over 7, comma, negative 12 over 14, which is negative 6 over 7, comma, negative 6 over 14, which is negative 3 over 7. And there we go. That's all that's involved in question 3. We'll move along to question 4 in the next video.